Hello everyone. So for today, we are going to talk about Mips Architecture. So this team consists of me, myself, Nurul Atika, my teammates, Amira Balkis and Adrina Filsa. So for this part, I'm going to talk about unicycle cycle for Mips Architecture. So in the tutorial session, we are given a set of codes that we have to run by using Dr. Mips software, and we have to see how does the code work throughout the CPU. So at first you have to put in the codes in the code section, and then after that you have to go to the execute and press assemble. So from there the Mips will execute exactly how by the codes given. So first of all, after assembling, we have to assign values to register T2 and T3. So you may proceed putting value to register T2, putting value to register T3. So firstly, the code at T1, T2, T3, it means that that code means that it will add the assigned value in T2 and T3. Then let's say for example, in this example we use 2 in T2 and 3 in T3. So 2 plus 3 equals to 5, right? So the result of 5 will be added to T1. So as you can see in the next step, the value of 5 is stored in T1. Next instruction is sub T2, T1 and T2, which simply means the value of T1, which is 5, will be subtracted with value T2, and then the result of that will be stored in T2. So the next instruction is just also the add instruction, which means the same thing. Then we proceed to the next instruction, which is add I. Add I is a bit different from the normal add because it means that it will add the value of the integer itself, which is in this code is 23. It will add 23 with the assigned value in T5, and then store it in the register T6. So as you can see, T5 plus with 23, that it will, and then the result will be as what you see in T6. Next is N. The code N T7, T2, T6 simply means that the binary value stored in T2 and T6 will perform an operation, and then the value of and then the result of that operation will be stored in T7. Next instruction is LW T1 0x00 T2. The LW in this code means it is loading word. To make it more simple, T1 is T1 is destination register. The code next to it, which is 0x00, T2 is word align address. So basically what does this code mean is that it will read the value specified in the word align address, and then it will store the value in the destination register we have declared earlier in the code, which is in this case T1. Let's say for example, at 0x00 T2, the value stored in that is 0. Then it will store the value 0 in register T1. Next instruction is NOR, T2, T7 and T1, which basically means that it will the binary value of T7 and T1 will be performing OR operation, then the result will be inverted. Hence, the inverted result will be stored in T2. Then the next instruction is OR, or T1, T2, T3, which is also the same thing. The only difference is that after T2 and T3 performing OR operation in binary value, the result will not be inverted because it's just OR, not NOR. So T2, T3 in binary value performing OR operation, then the result is stored in value T1. Next is SLT A1 T2 T3. SLT in this code means set on less than, meaning when the value of T2 is lesser than T3, it is true. Then when it is true, it will give out value 1 and it is stored in the register A. Else the value will be stored in 0. So in this case, in our coding, T2 is indeed lesser than T3. So from there, the result from this SLT will be 1 and it will be stored in A1. Next is sub, which is similar to the previous sub instruction, which simply means it will subtract the assigned value in T1 with T3, then store the result in register A2. Last but not least, the last code that we're using is SWA2 0x00A2. SW in this code means it is storing word, which means the value assigned in the source register, which is in this case is A2, will be stored in the word aligned address that we have specified in this code, which is 0x00A2. Simply means that whatever value it is in A2 will be stored in the word aligned address of 0x00A2.
Okay, next I will be explaining about pipelining. So basically, pipelining will load several instructions at the same time, and it is best explained according to its cycle. So for the first cycle, the first instruction, which is add, is fetch, and in this case, the instruction will run similar to the previous unicycle. Okay, and then next for the second cycle, the second instruction, which is sub, is fetch, while the previous instruction is decoded. And for the third cycle, the third instruction, which is add, is fetch, and the second instruction just now is decoded, and the first instruction is executed. For the next cycle, which is the fourth one, the fourth instruction is fetch, then the third is decoded, the second one is executed, and the first one is stored in the memory. And finally, the fifth cycle is when the fifth instruction is fetch, the fourth is decoded, the third instruction is executed, the second instruction is stored in the memory, and the first instruction undergoes the write back phase. So in this 5 clock cycle process, it marks the completion of the first instruction set, where it undergoes all phases in 5 clock cycles. So what happened to the remaining instruction set is it will repeat the same pipelining steps as before for the next clock cycle. So what can I conclude in this two architecture, pipelining and unicycle? I can say that pipelining is better compared to the unicycle because pipelining completes more tasks in a time, and thus it offering amazing speed up. So that's all from us. Thank you.